Hey guys, welcome back to Chili and in this video we are going to see how we can implement simple linear regression using the normal equation that we derived in our previous video. So here is the equation of normal equation. It is here and by using a normal equation we are going to find the regression line that we used to find using our built-in function or scikit-learn library. So it basically has the slope and intercept values. So here is our normal equation. So it has all of these parameters in matrix form, and it is x transpose, this is x matrix, and this is the y vector here. Okay, and the value of theta has all the parameters that we want to find, like slope and intercept and all. Okay, so first we will try to find the value of beta 0 and beta 1, or you can say the slope and intercept by using or I mean to say by hand, and then we will try to implement it using Python. And okay, so here we go. First of all, this equation can be also written as this form. Okay, so we just have to take this inverse this side, so we will get this equation. And here are our data points that we are going to use and find the best fit line for it. So here's our 1, 1, 2, 3, and 3, 2 data points, where this first column has all the x data points and this second column has all the y data points. And we know the equation of best fit line is y equals to beta 0 plus beta 1 x, where beta 1 is the slope of the regression line and beta 0 is the y-intercept of our regression line. So now what we want to do is we want to convert our data points in a matrix form. So to convert it in a matrix form, we always keep the first column as 1, since it is the parameter of beta 0 and we cannot leave it null, or we cannot leave it empty, so we are going to have it marked as 1 value. So whenever you multiply it with beta 0, then it won't change the value of beta 0. It means the coefficient of beta 0 will always be 1. And the second one is our input features. If we are trying to derive the conclusion from more than one features, then we will have more than two columns here and more than one parameters of beta, like a beta 2 and beta 3 here. And this one is our y vector, you can see here 1, 3, and 2. This one is our x vector, that is 1, 2, and 3. Okay, so I think this is pretty easy to understand. And if you perform the matrix multiplication, then you can see that it gives us beta 0 plus beta 1 equals to 1, and beta 0 plus 2 beta 1 equals to 3, and beta 0 plus 3 beta 1 equals to 2. So that basically is the equation of line. So we want to find the equation that we want to find the equation of line that best fits our data points. Okay, so here is our x matrix, and here is the transpose of x. Since we want x transpose and x and its dot product, and then x transpose and y vector and its dot product, so we have to find x. So here we have x value and here we have x transposed. Okay, so now we are putting it all together in this equation. So this is x transpose, this is x, this is the theta value, and this is again x transpose, and this is y. So here is the equation. Okay, so moving forward. Okay, so after we multiply these two matrices together, we get this value, and after we multiply these two matrices, we get this vector here. Okay, so now we can easily form two equations from these two matrices, or this set of instructions. So we get here 3 beta 0 plus 6 beta 1 equals to 6, and 6 beta 0 plus 14 beta 1 equals to 13. So now to solve this equation by hand, we need to multiply it by 2. So we have the same coefficients, then we can subtract it, and we will get only one parameter as unknown variable. So we can easily find it here. So you can see here we have beta 1 equals to 1 by 2. So now we can find the value of beta 0 by putting beta 1 into any of this equation. So we will get beta 0 value as 1. Okay, so now we have the values of beta 0 and beta 1, that is the y-intercept and the slope of the line. So we can say that the y the line that best fits our equation is y equals to 1 plus 1 half x. Okay, so generally what we do is we try to find this equation by using scikit-learn library, but now let's see what we can do with matrices and all. Okay, so here we are. Okay, we are going to find this equation only here, and I'm going to show you how we can find it using Python programming. And after then we are going to take the same example of engine size and CO2 emission and show the relationship between them. It is here. So we will first discuss this dummy data set, and then we will move forward to our actual data set. Okay, so the first step is pretty simple, that is importing the required libraries. Okay, so and the next one is I'm going to import the data set, or I'm going to convert it to an array, or I'm going to take an array of variables, that is 1 2 3 and 1 3 2 as our data points. So our data points will be 1 1 2 3 and 3 2, as you can already see it. Okay, okay, so now we are going to plot our data set here. Okay, you can see it here. We have three data points here. That is 1 1, this one is 2 3, and this one is 3 2. Okay, so now we want to find a regression line that best fits our equation, though. So it will be in middle of something here, like here. Okay, let me take a pen and draw it here. It will be something like here. Okay, so now moving forward to it. Okay, so now what we did here was take the first column as 1 in our matrix X. As you can see here, it is always going to be 1. Okay, because it is the coefficient value of beta 0, and our X feature, or the X data points, goes in the second column here in our X matrix. Okay, so to do this we are going to take np.once function that creates a column vector that has 3 rows and 1 column. Okay, so I'm going to run it. As you can see, we have 1 1 1 as our rows. Okay, so now I'm going to print the shape of X, so that is 3. Okay, and value of value of X is array of 1 to 3. Now the shape of X bias is 3 comma 1. So now we have to convert our X shape into 3 comma 1 shape, so we can add it together. And you must know that to add to matrices we must have the same dimensions. Okay, and if you want to have some matrices concept brushed up, then you might want to watch my previous video on matrices mathematics. Okay, and I will put the link in the description. Okay, so now we have to reshape our data set. So here is how we can do it. It is easy to understand, as you guys already know how to use NumPy. So here we have our X new. Okay, so now we are going to form a matrix. Okay, so to form a matrix we need to append our X bias data with our actual X new data. Okay, so here is what we are going to do it. We are going to append the X bias with X on X new on the X new with X is equals to 1, which means column wise. Okay, so we have our data here, that is 1 1 1 2 and 1 3, and we can see it is same like here. Okay, so now what we are going to do is we are going to transpose our matrix. So NumPy has already have a function called transpose function, so it will give us the transpose. Okay, so you can see it was the 3 cross 2 matrix, and it gives us a 2 cross 3 matrix here. Okay, now what we have to do is find the dot product. Okay, find the dot product between X transpose and X. Okay, so it is pretty simple. We have just to put a dot function with the variable we want to do the dot product with. Okay, so I'm going to run it. Okay, now what we want to do is find the inverse of this dot product. Okay, so we first find the dot product of this, and now we want to find the inverse of it. Okay, so this is the linear algebra function of NumPy library, and this is the inverse module in it. So it will give us the temp1 variable, and we are going to dot product it with the temp2 product later in this section. Okay, so this is our temp1 function, that is the inverse. Okay, so we now already have this variable, and now we want to find the value of this, and then we are going to multiply it with each other. Okay, now we are going to find the value of product of transposed x and y. Okay, here you can see it. So it is easy to understand. It's just a dot product. Okay, so now to find the coefficient value or the value of theta, we need to multiply it or find the dot product between these two variables. Okay, so let's name it theta. Then it is going to be temp1 dot temp2. Okay, as you can see, we have 1 as beta 0 and 0.5 is beta 1. Okay, so our intercept will be theta 0 and slope will be 0.5. Okay, and as you can already see here, we got the exact same value like we find it here. Beta 0 equals to 1 and beta 1 equals to 1/2. Okay, so now we are going to plot our regression line, and if you have already watched my previous video on linear regression from scratch, then you already know how to do it. So this is nothing, we are just going to plot our data on the data points, then we are going to plot our regression line with x variable and the y predicted variable using our regression line. Okay, you can see it is right in the middle of each of these data points. Okay, so now we are going to predict our values from our prediction line. So this is the basic function that will return the predicted value, and I've already described in my previous video called simple linear regression from scratch, and I will put the link in the description if you want to check it out. I have a thorough explanation on how we can find the predicted value and how we can calculate the error and all. So from now on it's going to be the same, so I'm not going to run the error part or the accuracy of a model part here. So I'm just going to show you how we can predict the value here. Okay, so for x equals to 3, if we want to predict a value, then we can check here. If x is 3, then it is going to be around 2.5 around. Okay, so let's check it. Yes, it is exactly 2.5. So I think this was easy to understand, and now we are going to move to the actual data set of our, like we try to find the CO2 emission from our engine size and all. Okay, so the procedure for that is exactly the same. There is no change in it. Okay, so let's check how it is going to work. So first of all, I'm going to import some required libraries. Here we need the pandas libraries to read our dataset, and our dataset is a fuel.csv file, and this is going to print out all the columns in it, and we are going to find the relationship between engine size and CO2 emissions. Okay, so I'm going to take the data as x data as engine size and y data as CO2 emission, as we want to predict the value of CO2 emissions based on the value of engine size. Okay, now we are going to find the type of data points. Okay, as you already know that in this section we took two arrays here. So here we are going to find out the types. So you can see it is a series, pandas series. So now we want to convert it to an array to fit in our matrix. Okay, so here is a basic function to convert a series into array, that is np means numpy.array, and the series we want to convert it. Okay, so here you can see we have now array. Okay, so now we are going to just plot our data on a scatter plot, and okay, so now we want to find the number of rows here, and I'm going to tell you why we are going to find the number of rows. Because see, now we want to have a matrix of, here we had a matrix of 3 cross 1 or 3 rows with 1 column, and since we know that we already have 3 data points, then we can easily say that we are going to need a vector, or a vector that has one value of number of rows with 3. But now we don't know how many rows are going to be there, so we need to find the length of the rows first, and we are going to create a ones matrix or ones vector that has n number of rows here. Okay, so I'm going to run it, and now I'm going to print the shape of x like we did in our previous section. And since we want to add this or multiply this matrices together, we need to reshape our x matrix. Okay, so it is 1067 rows and one column here. Okay, so now I'm forming a complete matrix that is putting the x bias or the one values in the first column and our x values in the second column here. Okay, so now I'm going to find the transpose of the matrix, and it is pretty much the same operations we did in our previous section. And this is the dot product of it, and this gives us the inverse of it. And finding the dot product of transposed x and y, and the theta value is going to be the dot product of two variables, that is temp1 and temp2. Okay, and now we have the theta1 and theta2 as our intercept and slope, and now we are going to plot our regression line so we can check it. Okay, so it fits pretty well since it is in the middle, and we use the cost function called mean squared error. Okay, so now we can predict our values for by our regression line. Okay, and I'm going to predict the value of engine size 5, and I'm going to say what is the CO2 emission when we have the engine size of 5. So we can say it's probably around 300. Okay, yes, it is 320. Okay, so I think this was pretty easy to understand, and I think this is the easiest method to implement in Python or to understand. And in the next video we are going to see what if we want to make our prediction based on more than one variable, like we want to take into account engine size and cylinders and predict the value of CO2 emission based on these two variables. Okay, so we are going to see how we can do it using matrices. And if you want to watch my previous video, then I will put the link in the description. And okay, so thank you so much for watching, and I will see you guys in the next video.